Go for it, Arthur.
Perfect. Thanks so much, Olivier. So today I'm going to present briefly, I guess I'll emphasize briefly, this chapter on deployments and code promotion. Part of the brevity is, though I didn't go physically to PositConf, I was following the videos, so that's where my attention and time were these past 2 days. Um, Also, I think this chapter, I was starting to look at the videos from the previous cohort, and it seems like this was joined with the environment as code chapter. So I wouldn't say that this chapter felt light, but it seemed like it definitely had less content. And I'm hopeful that if I'm brief, um, we can do the thing that, at least for me, has been maybe the most important part is hearing from others' experiences. Because the book gives some examples and uses, for example, promotes GitHub Actions as a deployment tool, but I'd be interested to hear what people do in real life. With all that said, let me get started. So I've got a few kind of broad learning objectives. First is through this chapter in the presentation, understand how and why we might want to progressively promote code from, I guess, as I put it here, from your computer to the cloud. So for kind of a low-level testing environment, a low-level development environment into production. Why not just push everything directly into prod? Um, Talk about the three environments, although I guess three is not necessarily a magic number. The chapter talks about three environments, and we'll discuss them today, but the chapter rightly points out that there may be fewer or more environments. And then lastly, taking GitHub Actions as an example, kind of see how we can automate the deployment process. Okay. Uh, I guess I was thinking RESPCT, find out what it means to me. So we got CI/CD, CI/CD, which I guess formally means continuous integration and either continuous development or continuous deployment or continuous delivery or maybe both, as the book points out. So I kind of wanted to break that down into some bite-sized pieces, what it actually means. So I think first thing is, continuous integration or deployment of what? So I think it's of code, and importantly, code that builds a project. So importantly, the project would be built from code and code alone. So oftentimes I find it more helpful to kind of talk about what a thing is not in order to define the thing. So to define things in the negative. So what that would mean is, not to have the code just on my machine, but have, the code exist in some publicly available repository. Not have, as I often see, even at work, these time-stamped versions of, Arthur's work today, .r, Arthur's version, or Arthur's work tomorrow, .r. It's insert your xkcd final .docx web video, or sorry, web comic. And I guess as you're building the project, you're not going to have manual or non-code actions. That the project should be completely defined by code, and that code should exist in a centralized place. Right. So that's one part of this. Um, I guess that's the code part. Now we're getting to the kind of integration and deployment parts. Is that this code will change over time as all code does, and we should really have this is the continuous piece. Have some kind of regular, I guess as I'm going to put like regular and right-sized changes to code. Again, I think it's easier to define this in the negative than to define this in the positive. So, maybe we wouldn't have any extremely long-lived branches where, for months and months we're working on a feature, let's say, but instead maybe we would want to have small, more atomic changes that we would make and then push those through the pipeline. At least I think that's what the model would want. Obviously, there are cases where you would want to deviate from this, but I think this is the spirit, at least of the continuous integration, continuous deployment, or continuous delivery, is to make incremental changes to the code base and then to kind of move those through the pipeline from dev to production. Another part of this is that this pipeline should be automated. Automated, I guess, at least on two levels. One is to have some automated pre-deployment tests. So before anything gets deployed, you would want to check that the code works or the code is good. And maybe these could be stylistic checks of the code, that it adheres to a certain team's quality standards, that code has comments, that functions have, thinking about R, that functions have uh, uh, Roxygen tags, or Python if they have doc strings, or that certain tests work. These could maybe be integration tests, or more sophisticated kind of integration type tests. That before you before you certainly send some code into production, you want to make sure that the code works, because it's really better to break tests instead of breaking production. As you're trying to write some code and deploy it, make sure that the code works at various stages, that it conforms to some of your expectations about how it should work, and do that importantly in an automated fashion. Um, so maybe you could think of this in your mind. I've regrettably not done this in practice, but in my mind, I'm thinking, just as we have for a package in R, we have unit tests that you can run. Each time you just want to check that your package continues to work, that it conforms to expectations you have about its behavior at every point in development. You run those on your machine in this kind of pipeline, the CI/CD pipeline world, where you're promoting things to production. Maybe those tests are run. Okay, some of them could be run by you, but maybe certain tests, or at least a suite of tests, would be run by some external tool that would check that your code works before your code could get accepted or promoted in the pipeline. So if you're developing, maybe there's some less restrictive tests that are run, but then as the code grows in maturity and gets promoted closer and closer to production, you want to make sure that a larger suite of tests work, so that your code that works on your computer also will work in your production environment. Um, Automated also deployment. So, maybe in the olden days, you could kind of copy some files from your computer onto a remote server, and that's deployment. Those kinds of manual actions are subject to kind of all of the human problems. And so really, I think we should prefer, instead, to rather than moving files manually, to have those files moved by a machine. And then also additionally, not make any ad hoc changes as things are done. That instead, as your code kind of moves through kind of a promotion pipeline that we'll discuss momentarily, that the project again be completely described by the code. That there not be some external tweaks to the code that are made, or to the production environment that are made as things are getting deployed, but just have your code capture everything, and resist this urge to make some small tweaks outside of the code. Here, I guess I'm going to Tolkien here. So three rings for elven kings under the sky. So I was thinking, the code, the book kind of talks about three environments for developers. This is from the book. I'll zoom in on this a little bit more. Yeah, we've got these three environments: test, dev, and prod. Oh, sorry. Go ahead, Olivier. I see your
Yeah,
hands raised.
maybe we can discuss a bit like the previous slide, if you don't mind, before going.
Sure.
I noticed I took some note on that. Like what the centralized mean is, like you're gonna have like some code centralization, which usually happen to be GitHub. But that does not necessarily, I mean, right now this is the way, but it could change. Uh, I think like the regular right side that you frame it super well. Like I think it's mostly depend of team and project. For example, in my previous organization, like if I did not get a push into production at the end of the week, the code could be forbidden. So there's also like, and then it died in some long branches, that's never can be merged, because like less you wait to push, more the work is done on the pull on the review. And then if the work is too big, it tend to be put away. So if you do like a big update, then you need to ritualize a big review, which is also like kind of hard in the organization point of view. So I think like the regular and right sized depend also on the capacity of the team. and on the project, does the project have enough budget for that to do like this? And I think it's become easier to make small change and review small change than bigger change. Yeah,
Absolutely.
I also added like you should automate deployment, but to still do not deploy on Friday. That should be like one check, like check the
Exactly.
calendar. If it's Friday, wait. Because like even if we want to automate deployment, I have seen way too frequently, like you deploy, let's say on Friday, and you want that to be done because you have some deadlines. Then you hack something very fast and you forget that. And the next deployment you forget, like because you have done that at Friday 4 p.m. And after that, you went into a weekend being totally like, especially if you have deployed something that was important. Like imagine you work at way more that week, and then you tired. Something did not work for some reason. There's plenty of good reason and plenty of bad reason, and then you do this ad hoc modification, and you don't remember. And next deployment is gonna happen again, unless like you remember on Monday like you have something to change. So I think like uh, yeah, this a lot depend of the team
Yeah,
cultures
but I
and
think you're right,
what.
Olivier. Like even if it's a team of two, like I was collaborating with one person, and not so long ago, and we were, I guess, rather inexperienced, and we had this bad habit of having like big changes, right? So it's like a week's work on a on a very complex Shiny app, and then we would end up having, or a week or two, and we end up having what we came to refer to as merge parties, and it was just, several hours of trying to merge something into main and resolving merge
Merge
conflicts, trying
conflict.
to understand like why did this change, because seemingly like you just have what's on like the two sides of the merge, and you're wondering like, well, which thing is right, because all of a sudden things that you did so
Yeah,
long
you don't
ago
remember
don't
anymore.
appear, they don't seem reasonable anymore, and you can really trick yourself. So even on a team of size two, I think it's pretty important to kind of merge things in early and often. If you have small changes, they're easier to reason about. And it's, I guess, also on the negative, it's kind of it's hard. I think it's harder to make these kind of merge conflict mistakes in the sense because you have this like project awareness of like what things changed and why, and what why it's important to retain a certain change, for example.
Yeah, that's very good points. And yeah, like everything can be ritualized on some way. Like you can have merge party, why not? But like let's say like the review is an external reviewers, and you're gonna send there like a review of like 105 modify. Voluntarily exaggerated, but it's impossible to review that. And and on the counterpart of like I get what you say, like when you say like sometimes you need a big like there's a necessarily big development that results in a big change, but then usually what people tend to do is they are scaffolding. Let's say like you have something that depends of something, you're gonna create like a flag that said like it's gonna be true, and at one point it's gonna depend on some conditional. But for once, you're gonna just flag it at something like to do is gonna be take one value, and later it can be updated. The stuff is like you shouldn't forget like you have like some piece that are scaffolded, and that just maintain of you are coding a true where it should be some complex logic
Mm.
and something like that. So that does us like a remark on that, or but it's like it's we are focusing here a lot on techniques, but I think this also like usually this is cultural change on some team, and cultural changes are way others. I mean, like especially like let's say like you sell something, a product or something, and you need to basically like budget 2 hours. Like this, they need to appear in some kind of budget. Like half an hours will need to be reviewed every week, or and that counts. I think this is harder than it looks on the organizational point of view. If others, well, I'm gonna go back, but yeah, go ahead. Sorry.
Looks like no comments, but do jump in if you have any. Um, So the book kind of talks about this. So previously I was talking about kind of promoting code without actually talking about promoting code. Um, the book talks about having three environments. Dev, which could be just really where you're crudely developing things. Let's think of it as your first draft. Test, which I kind of understood is where this draft gets a bit more refined, and then once that draft is accepted, it'll go into production. So you would want to have these three environments for good reasons. You wouldn't want to make some changes just to see, what happens and push them into production and break a production environment upon, which other people depend. So you clearly want to have things separate. Um, and I think you probably want to have, several environments where that would enable you to, work to do some work and have things be rough around the edges. Have an environment where things maybe get refined, and then have an environment where things are final. I shouldn't say final, where they go into production. Um, the book rightly says, here I'm focusing on three, but it could well be two. It could just be dev and prod. I've seen that fairly often, done that myself. Or you could have more, depending on the needs of the project, the norms of the organization, etc. But I think the point is that you need to have, two or more environments in which work happens. Um, uh, and then we'll come to like, and they need to be basically the same. We'll come to that point in just a bit. Um, but they're going to be linked. Trevin, go ahead.
Yeah, when they say environments, is that basically just a different branch? Like,
So it could, I think that would be one way to think about it. I think it's a little bit more, it could be more than that. It could, so depending on the project, it could simply just be a branch on GitHub or GitLab or your preferred version control hosting platform. Um, or it could be kind of more of an like an environment where let's say you have an environment for deploying a complex app on AWS, and then you have one set of logins and keys for dev, another set of logins and keys for test, another set of logins and keys for prod. And maybe also you could have different data that exist, or different permissions that exist in different environments. Let's say your project involves reading from a data source and then writing to a database, let's say. Um, maybe in prod, that's what you need. That's the project. But if maybe in other cases, for dev, for example, you don't want to be testing stuff out and writing to a database, a production database. So you would want to have another environment. So it could be environment you can construe as just a set of branches on GitHub or GitLab, etc. Or it could be much more of a substantial environment, a set of different environment variables, a set of different behaviors, a set of different data sources, different access, read and write permissions, etc. I mean, for me, more often than not, personally, it's just a set of GitHub branches. But for more sophisticated deployments, perhaps it could be quite a lot more. So I saw a hand raised at some point. Please do jump in. I'm not monitoring chat. It's a little hard for me to see chat
Yeah,
as
yeah,
I
it's
go.
it's it's me. It's Funny Kumar here. I totally kind of agree with you that but for us, I'm not in the R world, but in the SaaS world, the way it works is we have the data, which is in the production level. We cannot override the data for sure because data is only available once, but we take a liberty of breaking the data as much as possible in the dev area where we write macros or we test how it could be how well we can break it. Once it is a stable level, we'll push it to the test area where the reports are generated. And because I'm coming from the SaaS, we write a validation programs, we hit the programs and everything. And once we push it to the prod level, everything is independent, meaning there is no external dependencies, no macros believed that we have read. So everything, all libraries are clean, fresh. so that it produces from scratch. That's a level. So there is sometimes that we think that we have done it, and some leftovers done in dev area, like the piecemeal, right? I mean that copies or something else that might screw up the numbers. So that's how we read. But data remains stagnated. We cannot overwrite it, and dev is always for a workhorse, where you develop the programs. And in our situation, it is a folder, a Windows folder, or a drive, Windows drive, where it is only dedicated to development of programs.
Oh, very nice. Okay. I guess I'll now come to the promotion part. Again, keeping with my Tolkien theme. So instead of one ring to rule them all, and darkness bind them here, we've got one process to rule all of the environments and kind of in promotion bind them. So basically, these environments are linked. That you're going to have code that's going to fully describe your project and basically be the kind of backbone of your project in dev. And as it passes, let's say, certain acceptance criteria or milestones, you're going to promote it from one to the next. So you're going to develop in dev once you're satisfied with the product or want it to be further scrutinized in tests, maybe with a broader set of test suites or something, maybe some set of data or environment that's closer to production. You can promote it to test and then promote it finally once it passes all of the acceptance criteria from test to prod. So there needs to be a promotion process, and this promotion process, I guess, is kind of, to my understanding, a little bit more like a set of like acceptance criteria at each stage. It could be any combination of running automated tests and looking at the outcome. It could be a PR that's manually reviewed by an expert, a third party, a fellow team member who didn't do the coding. It could be looking at artifacts that are produced by within each environment and seeing how they conform to expectations, and then someone or something needs to basically then approve that code, and the code then will get kind of, if we're thinking about GitHub, and I'm going to come to this a little bit before, or a little bit later, you just merge the code into another branch, let's say. But you need to have this promotion process where you take, let's say, a draft code and then accept it into a stage of refinement, and then after it's been refined adequately, accept it into production. So I think a lot of this kind of, we've alluded to these before, but I think you end up having to engage in, excuse my kind of cutesy title, but I think it's maybe appropriate, as like environmental science. You've got these challenges where, if we have three environments, let's say, to take the book's kind of division, how do I keep them in sync, right? Such that I'm confident that when I promote code from one environment to the next, that it will work in that next environment. Most importantly, like when I promote from, let's say, tests, when I promote into prod, how do I have some assurances that code will work in prod? And the book, it doesn't formally suggest this, but these are kind of my notes a little bit. Is I think there are a few different mechanisms. Branches, configuration, promotion. I'll go into those in greater detail. So one is, for branches, Trevin went right to the point with a very incisive question, is like, are we just talking about GitHub branches? And that indeed could be the way that we have environments separate, that, the workflow might well look like we have some main branch, let's call that production. And then we'll fork, or we'll create a branch off of that. Maybe we'll add a new plot, and then we'll once we've worked on the plot a bit, it'll go into testing. someone will notice that maybe there's some bug that wasn't noticed previously. It'll get kind of pushed back to the feature branch to working on the plot. And then once the bug is resolved, it'll get pushed back to testing. And let's imagine at this point that everything looks fine. Then it could finally get merged into main. So in this way, like we have our an environment separate, and they're separated by branches, but then they're also kind of connected insofar as they're GitHub branches, right? So if I take main and then I kind of check out and create a new branch, there's going to be a pointer on this branch to some commit on main. So in that way, if these environments are completely described by code, then testing branched off in that way would be identical to main, at least at some point in time. And then when you branch off from test to this feature branch, the dev environment, then again you're going to have a pointer from this branch to somewhere on let's say the parent branch, etc. And then when you merge things back in, you're just kind of merging these sets of changes back into these environments. So in that way, your environments are separate. They're different branches in Git. And then hosted on GitHub, GitLab, etc. But then they're kind of similar, identical to the extent that you keep these branches up to date with, let's say, the ancestor branch. Yeah, this would maybe we could definitely go into a lot of technical detail, maybe about how to rebase and all the rest of that. But I think this is kind of the broad idea here. Yes, Olivier.
Yes, maybe like so we mentioned Git a lot. So a lot of that, like a lot of this workflow depend on Git. There's others like version control, like the new one is called Jujitsu, that is compatible with Git that I have not used, but I heard about it. But basically, like what's interesting, like when you switch right now, like it's recently become a Git command. You can use that switch instead of checkouts. I mean,
Okay.
checkout have other use, but like you can also switch from one branch to another one using the switch command, which then make more like easier, like make the English language closer to Git command. So when you switch, let's say from basically what you do is like you build some kind of main first. Let's say like my presentation from users as just a blank title that I build first, that I push on main, which will be a GitHub pages. And then I create a switch from that branch main to a development. And when and while I'm working on my presentation, I still have my titles on developed already, like on, let's say, like on GitHub available through the GitHub pages URL. And when I decide that it's finished on test, I'm always like can check with Quarto or whatever tool I used on localhost, and then I can decide to push it. But while I do that, like the Git switch between main and test will change my file inside of my repo. This is what Git does. It store multiple version of the file, snapshot, let's say. And when you change them, like you can, so it's important to, let's say, like you push a slide, like I say I work on 10 slide, I want to push it. Then maybe I was working on another slide, but I need to pull it back from main at once. So you need also like to remind, like when you are working on test, to add update test, because sometimes you work with multiple people that updates main, and your main on your local is not up to date with the main on the remote. So a workflow will be like 3 people push it to main. No, I pull to main. Maybe I want to work on test. Either I update my test from the main. That's basically create a merge from main to the test. And usually what we do is we merge I'm on test, I'm merging from main. And usually what we do is like we are on main and we are merging from test, like when we want to. So that's, I don't know if that's help, but like so like the quick sentence will be like, remember to pull data from the branch you want to update. So it does not have merge conflict, or it's on the right. So remember to git pull from the remote repo. So your local repo is up to sync to the no, your local repo is up to sync to the remote repo. So it's go both way.
Yeah, exactly. No, that's a great point.
And yes, I had other stuff to do, but I think I saw too much now. I see. Yes, sure, go ahead. I think that does it help like to understand that like, and it will be similar like if you have environment like you have a database, like usually like closer you go to dev. I mean, farther you go from main, closer the data is. So the data usually on test will be the similar than the database. Maybe the data you have on dev will be different because for some issue.
Yep.
You have
Yeah.
some this is layered from around main.
Yeah.
That's good.
And that's actually like a great segue, I guess, of sorts to this kind of idea of configuration. So, like one way that we can keep environments separate but similar is have branches. Another way that we can keep them separate but similar is through configuration. One idea is like you have dev, test, and prod. Maybe each one of them needs to have some set of environment variables, passwords to access particular databases. You need to point to different databases potentially, or different databases for each stage in the process. So for a dev, as Olivier was saying, you have maybe one kind of toy database that is good for that stage. For test, you have a different database that's more like prod but is not prod, and then for prod, obviously, you're pointing to prod database. So you'd have kind of like the set of the other things that would kind of characterize your environment, that would configure your environment, that would point kind of your device and like your environment to the things that it needs for its particular stage. And one way you could resolve that is kind of have like one config per environment. I think that's probably a bit too much. Or alternatively, as the book points out, maybe you can have one configuration file that's sort of environment aware. So if you're in dev, then you can't write to the database, right? These are configurations, and the database path is this. It's called dev DB, right? We're at dev, we're working with a different database than we are in prod. And then similarly in prod, well, here we need to write to the database, so the write permission should be true, and then the path to the production database is a different path. So this would kind of characterize these paths and environment variables that would allow you to work at different stages. The code could remain the same, but then this environment would kind of shift. And maybe one good way to keep all of this the same across your different branches is to have, again, as the book suggests, is a single configuration file that will kind of like toggle this as a function of which environment you're in. Maybe you have some environment variable that says, which environment you're in. I'm in dev, and then naturally, once you're in dev, these configuration properties will prevail. Or if you're in prod, these configuration properties will prevail. I don't have very much experience with this configuration thing, but it seems like a very attractive idea. I mean, also, you could extend this as well. Like, you have different passwords for different, let's say, cloud infrastructure, etc. Yeah. I don't know if others have experience in this area.
I have a lot, and I have a love-hate relationship with it.
As someone who has experience with
I have some slide, but like we can stay on that. Like what's in like at this like first like just like to nitpick on the book, I think it's better to have user defined write and read and not having defined by the YAML file. So it should be like, let's say if you use a database, the database users should be the one that's monitor like your write on read and not inside, not defined. But on the counterpoint of it, if you work with Ansible, Ansible will define, which is one of the infrastructures as code.
As code, yeah.
We'll have this kind of, I mean, because like you want to, the Ansible can be set to set up PostgreSQL database or whatever set the database you want, and then you have like flags that allow you like to these users can use. So maybe like this is also like the habit of defining Ansible where you set up that. Yes, I have like, so I think it's good, but there's like I have like this, especially like this kind of stuff, like, 6 line is good. But my worry is when I don't know if people have used YAML, but maybe we should start to say like YAML is nested list. So dev is the first level, and then write and DB pass are like on the second level and they are similar on dev and prod. So and you can nest a lot. And you can also inherit, I mean, I don't know if you mentioned inheritance letters, but you can also inherit from various level previously, as you can set up a default. I actually I like that default ID. I prefer the default that inheritance sometimes, which the default is a setup on the config package that you can use to read that file. But my advice you shouldn't use too much logic in the config file. Too much code logic. So if you have code logic, by code logic I mean, like, for example, in the config package, they mentioned a trial. Let's say like in dev you want to run the certain number of trial, while in prod you want maybe more. They start to be code logic. And more you put logic, I think logic business should be in code. And YAML should just be up for environmental variable where you switch the flag. If you put logic into the YAML, code logic, business logic, I'm afraid like it's gonna be a pain to maintain. Because then you get like the YAML file should be like set up at the beginning, kind of, when you set up like your logic. But if you are modifying stuff in the YAML file while also building pieces, this become very hard to maintain. And similar, you don't put data into it. So some stuff should be data, and that should be like linked to some other storage or something. But yeah, this is just a few remarks that I have done. I don't know what others, but like and YAML like are a pain to write. They are very susceptible. So for example, like there's like ton of internet about them, like people complain a lot about them, but small file, absolutely. But like when they become like 100 line of pseudocode, when you reinvent a language, this should be moved to a language. I don't know, like yes. I can give example, like for example, some dashboard that we are doing specific calculation. Let's say like you want to do to do like a dashboard that's pick some, and then the calculation is done by picking nested stuff into the YAML file. And I think that should be moved to the codes. So, but yeah, that's my 2 cents.
Yeah, got it. Got it.
And
sorry, I was rebuilding to prevent.
Yeah,
okay, good.
I can look what I have like I can look what I wrote on that quickly, but I think this is mostly we need to go. It's rebuilding. Yeah, the config,
sorry,
like you should definitely look at the config.
there we go.
The config package, it's nice, and you can also do config. You can also use our expression inside of your YAML file, but this is the place where like you should always tinker, like, and for file paths and stuff like that, this is fine. But when you start to implement complex logic, be very careful.
Yeah. That's good advice. Yeah, and I touched on this earlier, just for promotion, there kind of needs to be some process whereby you come to a decision about whether code from, let's say, a lower level environment, so if you're in test from dev, should be promoted, right? It could be as simple as running some tests, either by a person or by some sort of service that would run tests. Classic code review on a PR, and then finally, once all tests have been passed, everyone's satisfied with the result, then to merge that code into into the branch of the environment where you want that code to be. So if you're promoting code from test to prod, then you would need to merge the code into the prod branch, which I guess from the book was main. In this case, that's probably a typical decision. Yeah. And then lastly, on this kind of point of deployment, so we've got the book kind of takes the example of GitHub Actions as a mechanism for pushing code into production. And I just kind of decomposed it here, and then I have a kind of an example, kind of a toy example from kind of work a little bit, which I can show. It's publicly available. Where typically you'll have on GitHub Actions, you'll have like a workflow file that's it'll be in the .github/workflow or workflows, I forget which it is, directory, be a YAML file that says, on events. So if you're familiar with Shiny, it kind of feels a bit like Shiny. It's like an event listener. It says, when these things happen to the repository, then do some stuff. And I think typically it'll be when someone pushes to main or merges to main, then you'll want the deployment job to be done. And so with GitHub Actions, your kind of workflow consists of a set of jobs. And those jobs, so it could be one or more jobs, but let's just imagine for simplicity that it's one job, deploy, whatever that means. It'll be done in an environment. You have to have some operating system on which it works. Very often people will put this, runs on Ubuntu latest, or maybe they'll pen a version of Ubuntu or something like that. With GitHub Actions, you can also use Windows and Mac. And then you'll have a set of environment variables. I think probably the minimum thing is you need to pass to GitHub Actions just through this expression, although with some indentation, basically your keys, which would allow this is the way at least I've internalized it, your secret, so your GitHub key, personal action token or authorization token, I think it is, that enables GitHub this service to act on your behalf. So you can kind of think of it as, this is an API that needs to be authenticated to run, and you'll just pass it your key to do the thing. I've not done this before, but I imagine that with this env bit, you can also have other environment variables as needed, but I think this is kind of the minimum thing to get something running. And then jobs, so jobs consist of you need to be done in an environment, a computational environment. So a base operating system, maybe some set of environment variables, and then they consist of steps. And those steps will either be actions. So you'll find there's kind of this marketplace of GitHub actions that other people have written that do things. So for example, if you kind of look into the details of and use this, I forget what the function is called, but basically it allows you to publish a website, let's say your package website. Behind the scenes, it utilizes, among other things, it utilizes a GitHub action, which just publishes your content. To take steps on your behalf. So you can use these kind of little Lego pieces, these Lego bricks that other people have developed and upon which the larger community relies, or you can write your own things as you would from the terminal. So if I'm in Ubuntu, for example, I can issue some commands. I can install packages because if I'm using the operating system Ubuntu, it's a Virgin operating system that just has the standard things on it. It may not have the packages that I need in order, as dependencies for the R code, let's say that I want to run. So I'll need to install those system packages. And maybe I would want to do some other stuff from the Linux command line. So you can do these things, one or both of these things in combination to have things happen. So again, GitHub, for those unfamiliar, probably those in the call are more familiar with this than I am. Basically, you have a workflow that'll kick off when GitHub sees that something has happened on your repository. it'll kick off one or more jobs, and those jobs, need a computational environment, needs an OS, needs a set of environment variables, and then you have a sequence of steps, a recipe of, first, first you wash your potatoes, then you peel your potatoes, then you chop them up, then you throw them in water, etc. A set of steps, and those steps can be either steps that other people have written. For example, there's like install Quarto that exists on the marketplace. If I'm not mistaken, there's install R. Or you can kind of use your own command line Kung Fu mastery and do those things. This is, I think, the last slide that I have. So I was just going to look into an example, which is probably a pretty badly written GitHub. Let's see, GitHub action. Okay, sorry, forgive me. Zooming in does some untoward things here. So for context of this project, a collaborator and I, we basically wrote a Stata package that, among other things, that brings some of the goodness of use this to Stata. So in Stata, for those who are unfamiliar, and hopefully you are and will remain unfamiliar with Stata, docs kind of we don't have nice things in the ecosystem of docs pages like we do with the package pages in R. And also the packages need to be written, the docs need to be written in it's kind of like a proprietary language that is a messy amalgamation of like LaTeX and kind of precursors to Markdown. It's hard to write. And so what we wanted to do is we wanted to have a package that basically took the docs that you could write in Markdown and then kind of built all of the docs, and then importantly for this GitHub action, built a package website using Quarto. So that's just a little context. And so here I have like an on events. So push as anyone pushes to master a main. So here we're providing this to other people. We don't know how they're going to name their main branch, but we took a few conventional choices. So if anyone pushes to one of those branches, then build the package website basically. And it's a job with an R package that I built for this custom purpose. Runs on Ubuntu. I'm passing it, the secret so it can do the thing. And then we have a series of steps in this job. So first, there's a check out the project, set up pages. I haven't touched this in a long time, so I'm struggling to remember what half of these things do. Here from rlib, you have the setup R. So I'm installing a version of R here. Another one installing Quarto. This is something else that's from the R ecosystem marketplace. Installing dependencies. This is ungodly kind of bash here. Probably should have done some line commits, but these are all of the dependencies that are needed for my particular package. And then, we're installing dev tools to install my package, which I have on GitHub, installing here, running a command that creates the site. And then once we have it, we're uploading the artifact, the website to a particular folder the GitHub expects, the docs folder, and then some other stuff right here. So don't take very seriously or as an exemplar like anything that's written here, but hopefully it kind of conveys a little bit the idea of what you can do. You can have this this runner that basically will, on certain events, typically pushing to main or master, build a website here's just an example of this. I don't mean this to be like shameless advertisement. It's definitely not meant to be that. It's pretty what do you call it, amateurish, but here we built a Quarto website that has the docs for our Stata package. So all of this is kind of built through this runner, right? Yeah, I'll stop there. And I'm honestly, I started to draft some questions because frankly, I'm very often more interested in what all of you guys have to say than in the book, to be very honest. So I'd be interested, to hear what your experience has been with kind of putting things into production. And also, I mean, for this deployment step, whether GitHub Actions is still the best game in town or other people have different preferences. There's one I stumbled upon today, I think it's like black site or something like that. Yeah. Anyway, I'll stop blathering and turn it over to you. Thanks.
Thanks. I have remarked, but I'm waiting for others. Yeah, one point, and maybe connected to environments. Like basically, like your production environment is an Ubuntu, where you run a sequence of steps. You can also like I don't spend too much time on GitHub Actions, so I don't know. But you can also pass Docker environment. And then the idea is usually like you have a project where you use Dockers to build everything. R is Dockerized, everything is Dockerized. And then you move that Docker image. I mean, you provide that link to that Docker image to the runners, which happen to be a VM. I mean, it's not exactly a VM, but like it's represented as a VM. And then this is all like because like the question was like, how do you move from test, prod, etc., etc. The prod here is a VM or similar as a VM inside of GitHub, where a specific environment is built. By specific environments, it's built like operating system dependency that you clearly defined, and then it's built like as air dependency, which you also defined, and then it's do a bunch of stuff to deploying, which is moving to doc. You probably like also on the same time, like the repo is probably configured, like the GitHub repo is probably configured in some way, so it's ready into doc to deploy the website. So even if you see like here, like the funny stuff is like this, the UI is probably defined on the repo side, and it's not I mean, it could be documented, but it's not into the code. I have done that, so it's not like shame, but it's just to say like, even if you want to have everything as an infrastructure, sometimes you still have like some UI piece that you modify by hands that needs to be documented somewhere.
Yeah. Yeah, for us, it was like for the website, it's just like, the website will like this script finds some things or doesn't find some things. Like the package icon is optional, right? So if someone makes it, the hex icon will put it there. If they don't, we won't, right? So you're absolutely right, and that's kind of documented more in like the user-facing documentation. Like this thing is actually ships with the product, so someone just they install our Stata package and build a package with our package. And then if they host it on GitHub, then this does the thing. That's kind of the idea. But yeah. No, you're absolutely right. It does violate the rules of having everything. It doesn't fit into this like thing of like, actually everything should be defined by code. Yeah.
We try, but like I just want like there's no shame at all. Just saying like, yeah, there's like we try as much, but there's always like some stuff that does not, and that's fine. One of the points is like why, and that's also one reason why a lot of us are on Ubuntu. It's because Ubuntu is usually the prod environment, so we are closer to the prod environment by having our development operating system on it. But you can still run a VM with Ubuntu and doing something similar. But that's required time. So like also like this is something like you should think when you build a project. And for example, and because like let's say like you are all on Mac or everyone's on Mac, you can run Mac on GitHub runner. It's just more expensive. The Ubuntu runners is the cheapest one. That's one point that I wanted to mention. I have also like instead of like and I have a small script for that for some of my work. Like you can also, instead of depending of a config variable, like which config does. So what's interesting is config is what it does is the file. You need to put a YAML file that you need to provide to everyone that need to be in the repo. So you shouldn't put code into it. That's gonna be called depending on an environmental variable that you write somewhere. And you cannot, but another way of doing that is checking which branch you are in Git. So, and then depending on the branch you are in Git, it's gonna fork or flag between the place you want. So let's say like if you are on main, it's gonna target the correct stuff or try to target the correct stuff. But if you are like on non-main, it's gonna flag to other stuff. So it's another way
Interesting.
of doing it.
So is
You
there
can
kind of
use
like
like
a Git version of like a like I guess there must
I
be a Git
use
command that would return the name of the branch
yeah.
on which you are, right?
There is a Git command that does that, but I remember when I was stupid and naive, I was parsing the return of that object to read it. Well, so you can Git return a string if you had, I don't remember the commands, and then you pass that string to correct, and this over engineering. So you can just like there is a get package, which is like an interaction with the C library of Git, which has the command. So you can just get, you can pass the code if I found it. Like this is something like that, for example. Get git info shortends. Like I'm gonna copy paste into the chat. Paste. No, why? Oh yeah, it's a bit slow. So and then like if it's the
Awesome.
and then you can exactly like you can switch depending on that. Like have an if I'm on main, I do something, and if I'm not on main, I do other thing. So this is another way. And then after you can still use the configuration file to do what the other things are. So that's an easier way to do it. What other stuff did I notes on that? I mean, I think. Oh yes, this part is important. So Git implements what we call a Git hooks, HOOKS. That's depending of what happening in the Git places is different. So the author mentioned like post-merge and pre-merge. Post-merge exists. This is a correct Git hook. Let's say like it's used some stuff, but pre-merge is recent. It's basically like what you do before doing a merge. And it can be like if you type git hooks, for example, you're gonna find them. I have them also. Like I can also like copy paste, copy. Sadly, there is not a good package for that into R. I looked into it a few weeks ago. Oops, I copy pasted too much. Well, that's fine. You have plenty of link now. And you have like so use this have some. But if you look into your Git repository, well, I can share my screen maybe if you want, as you
Sure,
like.
go ahead. Yeah.
That's gonna be fast. You need to stop sharing,
Stop
I
share.
think.
Yeah.
Yeah.
Yeah, it should be yours.
I'm gonna share quickly. So it's useful to learn they are here. Share, sure. What is it here? So, well, the documentation of Git hook is here, so you can read it. Like there's plenty of them, and there's no pre-merge. Like this is the name, the other name, and they recently added the pre-merge ID. So, but you can find them on Git if you go here on Git on hooks. You have all of this one that are example, and if you remove the sample, let's say like the pre-commit sample. What it does is just it does something similar like of the Git short end. It look where you are and according to where you are, it change stuff. But this is just a small stuff that check if the file you are committing have non-ASCII character in the file. Stop that. But like the default is like Git can only read one, so you can only have one pre-commit. So if you want to have multiple stuff before you commit, let's say you want a linters, you want a bunch of other stuff like that, you need to, this pre-commit file should be like just a loop where you loop on another repository. And there's a Python package that does that, and you have a nerve wrapper around that package. I don't remember the name. Maybe I stop it. I can find it, but it's less developed. So they are here and they are useful. Why do I mention that? Is basically like running the test and everything like that can be also run locally, or you can also use Git to do this kind of stuff.
So practically speaking, Olivier,
this hook.
I guess these hooks would, like as you issue a command to say like merge or something like that, then these hooks would come into play is kind of the way it works.
If you run some kind of, basically like if you run some Git commands, it's gonna run this stuff. Depending, like let's say like I'm gonna if you have time, like I can try to do that fastly. Let's remove that one. Rename. So okay, so now it's like the pre-commit is available in my Git repo. And by the way, you see, this is not updated as code. This is updated by me by hand. Let's git switch to main first. So I'm on main. Let me touch a new file that's gonna be Beyonce. I'm terrible with Beyonce, so bear with me because I don't know this keyboard. Beyonce. This is my Beyonce trick. If you don't know the Beyonce trick, oh, it's here. I have it still. If you search this accent, this is the Beyonce accent. It's used in French, that's why I know it, but this is how I get it. Oops. Copy paste it. When I have a keyboard that I don't know what, but here I know. So I use the Beyonce trick. And search Beyonce, paste. And who cares, like Beyonce? Okay, so now I have a Beyonce. As you can see, it's not a nice key name, so I'm gonna try to, I can add it to my staging, so it's its stage. But if I want to git commit, I shouldn't do that in main. So git switch Beyonce. Let's move it directly to it. Okay, and now I want to commit it. Test. I'm not very original. And see here, I can't. If I echo my, oops, can I move that chat, please? See, you have like, so what Guy is saying, I try to put a non-ASCII file name, and it can be problematic, but it's a stupid example. You can do more complicated stuff on pre-commits. You can do more complicated stuff on merge. You can do more complicated stuff of post-merge. But this is the idea basically, and it can be done locally or remotely on your Git servers or using a client like GitLab or GitHub. I mean, not a client as services. And it tells me like if I want to allow that, I can also like change and allow ASCII file as true. That was an example of Git, and you can learn about it. And there are plenty of one, like you can do that for rebase, you can set up a specific message, you can do a lot of with it. That was it. And it's useful. I mean, one of the most used one is secret. So if you don't want to commit secret because like once you commit the code on your Git, as you nuke your Git, let's say like if I want to touch CP our environment to here, let's call it secret. And let's secret. They are not my AWS secret. This is fake AWS stuff. So they are here, and if I add it, git, GST, you see my secret are here. I'm gonna remove Beyonce so we have no trouble with it. It's Magisk. And here I have like, if I want to add, no, I have secret here and I can freely commit them to the repo. Bad stuff. And here now, like somewhere in Git, I never know exactly, there's my secret somewhere. And if I push that, if I do a Git push, my secret are gonna be in the local repo, which happened, remote repo, which happened to be public. So usually there's a pre-commit hook that check for secrets and does not allow you to pass file. If I had set up that here, I would not have been able to do that. And if you Google secret hooks, you're gonna find it. So it's useful stuff to have also like in your environment to avoid mistake like that. That was it. So yes, well, it's important like this is stuff like that's gonna avoid you like I tend to be very cautious with my commits, but even me being very cautious of my commits, error happens. So you need to automate that. I mean, automate not making errors. Yeah, that was it. I think I don't have much to add. Yes. I think it's there's a lot of question remark by that. So basically, like I still want to emphasize like the fact that there is technical aspect, but there is a lot of cultural aspect on code deployments and on this kind of stuff. And by cultural aspect, I mean team cultures or whatever you call it. But like you need to be organized. You need to have a discussion, I feel, with your team, saying like, look, how are we gonna work? Like we can implement all the Git hook you want. You can implement all the. If we don't set up a workflow and document that workflow, and decide, sometimes it can be at the project level, sometimes it can be like at the team level, sometimes it's even at the org level, depending how big the org is and the team is. So this needs to be discussed, I feel. That was it. Thanks, Archer was great. And I think you are 100% correct. Like sometimes environment here is used definitely loosely.
Yeah. Well, thanks so
Quick
much.
question. Hey, quick question, everyone. I mean, I know that I was just waiting for this question. It might be a very naive question, like where do I start with GitHub Actions? I mean, I'm totally new to the GitHub and all these things. So where can I start with 101?
Okay, first start by Git.
Sorry?
You should first. You should start by using Git.
Okay. Yeah,
So
my introduction to Git is through RStudio, like where I try
yeah,
to push it.
that's a good that's a good start. So the API Git with R is a good one. I'm gonna post the link on Slack later. So API Git with R is a good start. It has a lot. For GitHub, I remember GitHub, they have like tutorials or documentation that long time ago was very good. I have not done it since long time ago, but I think long time ago it used to be very good. And then I'm gonna pass you a link to another course that's inside of a box. I don't know if you know what box is stuff that require you to identify. So I'm gonna pass it now because I document by another one like that's discuss it. Where's the Zoom chat? And I should pass them later. Happy get with us. Thanks, Humor. So this is like it's gonna link you to it's a PDF from a course from Dirk at Budel, that's an R programmer that do a lot of stuff too, and it's do an introduction of GitHub Action, but he also recommend that you go through the basic tutorial of GitHub Action inside of GitHub. What other kind of resource? And there's like tremendous amount of discussion of which workflow should you use, etc., etc. My best advice is you should start simple, make error, and adapt. Because you're gonna do errors. Like the only big error you can do is like basically like using publishing secret on GitHub. That's the most dangerous stuff you can do.
Okay.
So this is like what's the only point, like you should always be careful. This is why you know, like in my workflow, I always use GST, and GST is my alias for Git status. So before committing to GitHub, I always check what I'm committing.
Okay.
So this is Git status. And because I tapped that too much, I have in my bash rc, which is my my command my some stuff that's environments, that functional environment that are loaded from my shell. I have something like gst equals, I don't even remember if it's quoted or not, git status. So it's implemented in my brain, like every time I tap, because what you want to avoid is like you can also do you can shortcut the Git so Git have multiple layers. You have like the staging, like your environment, what you are in, the staging, and and then directly in the Git storage, and you can basically like go faster and move from what you are doing to the storage by doing git commits minus a, which I tend to be like I'm adding a storage, then I'm moving, but you can shortcut that. So this is kind of workflow, like you are fine if you're not dealing with secret, but you should avoid doing it while you are in your code. You can have secret and stuff like that, or person or PI. Like if you are dealing also like with personal information that's private, you know, like security card numbers, social security numbers, I don't know, email, stuff that's allowed to identify someone. And that could be in your code because you are testing stuff. You should be cautious. By yeah, GitHub Action documentation are good. If my mind, I mean, if they are still good, yeah, they were good. Other
Sure.
question?
Let me try working on it. But yeah, nice piece of information that I learned today. Thank you. Thank you, Oliver.
Yeah.
Thank you, Otto. Yeah, it is
I'm gonna type and
something
yeah,
very nice to learn about the new technologies.
yeah, and like for the Windows users, I know like Windows